Previously, whenever we've talked about kinetic energy, we've only been dealing with translational motion, so an object moving along some path but not rotating. And in today's lab, we're looking at rotational motion. So when an object is rotating, it also has a rotational kinetic energy. And if an object rolls, then it has both. It has translational motion and rotational motion. So its total kinetic energy then is the sum of its translational kinetic energy and its rotational kinetic energy. And then also depending on the object's shape and its mass distribution, so how its mass is distributed away from its axis of rotation, then more or less of that kinetic energy is going to go into translational or rotational motion. And that's what we're going to be looking at today. So we're going to roll different objects down a ramp and then compare their final velocities to the prediction that we would get from conservation of energy. So at the top of the ramp, they're going to have some potential energy, and that potential energy is then going to be converted into kinetic energy, a combination of their translational and rotational kinetic energies. And from that, then we can predict what their final velocities should be. And so then we'll compare our predictions to the actual velocities that we measure with our video capture. And so the setup for this is very simple. We're just going to set up our stack of books, our Hot Wheels track for our ramp, and then roll different objects down that ramp and film it with our smartphone. The first thing we need to start with is a level table. And we're going to need the table to be level because we'll need to measure the height of our stack of books relative to the end of the track. And if the table is uneven, then that's going to add some extra height difference, which will mess up our measurement. So let's start by just moving our stack of books over here. And you're going to want the stack of books to be no more than around 15 centimeters high. If you have it too high, then the track is going to be too steep, and then the objects may slip instead of roll. And we need them to roll without slipping. So let's just tack this down here with a little bit of duct tape, and the duct tape shouldn't damage the cover. This is a slit cover book, so it should be all right as long as I remove it once I get done with the experiment. Then we just need to place the ruler here at the end of the track, and this will be used for calibrating the distances later on the computer. So just place it here right at the end of the track, and it needs to be parallel to the track as well. Then we just need to measure the height of our book stack. And we're going to use the tape measure for this. We can't use the ruler because it extends past the end marking, so that won't be accurate. But just measure from the table up to the top of the book stack. And in my case, it looks like 15.5 centimeters, so that would be 0.155 meters. And that is just a little bit more than the 15 centimeters I suggested, but it should be okay. So we've got three objects to choose from: a solid disc, a hollow cylinder, and a hollow sphere. And you need to choose at least two of them for this experiment. You could choose all three, but you need to choose at least two of them, and then we need to measure their masses. So just grab your spring balance for this and make sure it's zeroed. I've already zeroed mine, so I'm ready to go like that. And then just get a small piece of duct tape. So just use the tape to tape the disc to the spring balance hook, hang it like that, and then record the mass in kilograms. And then you'll do the same thing for the sphere. Just like that, record the mass in kilograms. And then if you choose the cylinder, you should just be able to hang it directly on the hook like that. So again, just record that mass in kilograms. So the last thing we need to set up is the camera, and you're going to use your smartphone again for this, as well as the wood block and the rubber bands to make a stand. So just start by wrapping the rubber bands around the wood block. And then you're just going to insert the phone in behind the rubber bands, and that will hold it just like this, and you'll want it in the horizontal orientation. So just set up the phone right like this so that it's pointing at the end of the track. Make sure both ends of the ruler are visible, and then the end of the track should be roughly in the center of the image. And then just make sure that the track and the camera are parallel to each other, so everything here needs to be parallel to each other. Just a quick reminder here, if you're using an iPhone or an iPad to film your experiment, then you need to go to the Settings app and scroll down to Camera. And under Camera, go to Formats, and make sure that you've selected Most Compatible. If you use the high efficiency format, then the program tracker will not be able to use your video files. It won't be able to open them. So just make sure you select Most Compatible, and you should be good. And that's it for the setup. Now we just need to collect our data. So we'll start recording on the camera, and then one by one we'll roll the objects down the track, and we need to do a separate clip for each one. The program tracker on the computer can't handle very long videos, so keep them short and do a separate clip for each object. Alright, so I've started the camera recording. I placed the disc right here at the top, right over the edge of the book, so that's where I measured the height. And then don't give it any initial velocity. If you do that, then it'll mess up the conservation of energy predictions. And then just let it go. Alright, stopped the camera, started the camera, do the same thing now with the ring. Alright, and again now we're going to do the same thing with the ball. And that's it for this experiment. You'll just want to export the videos to the computer and then track the motion of the objects as they roll down the ramp. And you probably don't need to do it for the entire length, but at least just do it maybe for the last half of the track, and then follow the instructions so that you get the velocity right here at the end before it rolls off the end of the track. And as always, read your instructions carefully. They will have more information than what is shared in this video, and good luck on your experiment.